In this video, I am making some lock bar inserts. Lock bar inserts are just that. They're inserts that go on the lock bar. They're just a replacement for carbonizing the titanium, and it adds a little bit of flexibility in the design, so I prefer them. I coupon mill them out of AEBL stainless steel. I prefer that material. It's not like my favorite material to work with, but they're one-off pieces, and they're pretty simple, and it's just a good steel. I get a good hardness out of them. Setup for this should be pretty simple. All my tools are preset. The last video you would have seen, it would have been me just getting this machine. I now have over 6 months of experience with it, and so I'm pretty comfortable with it at this point. There was definitely a learning curve, but it's a pretty easy machine to work with once you know kind of what's going on. I'm going to go ahead and set the Z offset for this piece. One of the things I did have to learn about this machine is you don't set 0 on this, you set the height of the fully compressed Heimer, which is pretty simple once you know how to do it, but until then, it can be kind of a complicated process. Once the measuring's done, I just go ahead and start the program. It's a pretty simple program from here. I start by facing it, and then I helically bore out a couple little holes with a 16th inch end mill. I usually run this all with coolant, just to be clear, but this being a video, I decided to film it without coolant and just to kind of see what would happen. And everything worked pretty well, actually. And then I go through and I ramp toolpath down this piece. It's better than plunging. I like ramp if you're doing slotting, especially this is a 16th inch tool, fully slotting steel without coolant in this use. And so it's pretty good. And then I come through, I do a couple chamfers, set chamfers for tools, drill a quick hole, 16th inch drill, and then I finish slotting it out. The smallest tool I use here is a 1/32 inch end mill to bore out the hole for the detemp ball. And that was a pretty quick process. That happened earlier. Here's a slightly better view of what it looks like. There were some other lock bar inserts cut out of this bar previously, but this is the one I just did. And I can go ahead and just pop it out with my fingers. It's a nice way to do this. There's a little more cleanup after the fact, but for heat treat, having them contained in this is really nice because they're pretty small parts. And then heat treating those with the foil bags, it's just kind of annoying. So this is the cleanup of the part. This is a pretty simple process. I usually do this post heat treat, but being that I'm testing the detemp ball on these ones, I don't think I actually said what I'm doing. I had some detent lash in the newer ones I made, so I moved that position, and I'm going to be testing this in a second. One of the reasons I haven't uploaded videos recently is I've been very busy. It's kind of an excuse more than an actual reason, but partially is because I've really stopped enjoying the process of making these YouTube videos, mostly due to technical reasons. Not so much that I don't like making videos and I don't like posting videos. I do enjoy that process, but mostly due to like handling footage and stuff like that. Man, it sounds like I'm going to a sponsor segment. No, I'm not sponsored. What I did end up doing is I did end up getting a camera. I got a mirrorless camera, and I'm doing all the filming of this on that camera, and that's really helped with the footage and stuff like that. So that's been a very nice process. Anyways, now that the lock bar insert's cleaned up, you can see it here. It's a pretty nice little piece. It's pretty simple and not super high tolerance. Once that's done, I'm going to go ahead and put a pin in it, literally. A 16th inch locating pin goes in this, so there's going to be 3 points of locating the 2 screws, and then the pin. I just find that to be the most accurate. It's also super easy to locate with pins like this, so I use them where I can. There's several pins in my design just because it's super easy locating. Once the pin's in there, I go ahead and put the detemp ball in. Like I said, usually all this happens after heat treat. It's just being that I'm testing this piece. So I use ceramic balls for this, or I just use whatever ones I have. They're 16th inch ceramic, grade 5. I forget the exact type of material it is. It's like SIN something. Yeah, it's a pretty easy process. I just go ahead and press it in there. And then I go ahead and put it in the handle. It's a pretty quick process. I didn't film most of it, but this is just the final bit of it. Goes in there. It's nice and flush. Perfect little piece. And here is it in action. It ended up taking all the detent lash out of it, so exactly what I wanted to do. I moved that ball location by 1/4 thou, which is quite a bit, actually. But I had some changes in how I make the blades, and so I think the tolerance has changed a little bit on those. And so we'll see if they stay this way. It's a really easy thing to change, and once you fix the detent lash, it doesn't matter to anybody what that is. That's not something that's going to impact anything once it's gone. And so, it's not going to be an issue for the end user, but it, with detent lash, it of course is an issue. So, yeah, really happy with how these have turned out, and these folders are getting pretty good. So I'm going to go ahead and start the actual run of these. I just made one of them. This run, I'm going to make 7 more of them. I have 10 or so folders that I'm going to be doing in this next batch, and so I just needed to run the rest of them. And then this one gets to use coolant. And so I think this was a 40-minute toolpath for all 7 or something like that, so not super long. While that's running, I'm going to go ahead and start the heat treat oven. It's a 120 volt, so it takes its sweet time heating up. Here you can see the finished machine thing, and the reason why I try to keep them in the coupon is because heat treating this whole thing as a bar is much easier than heat treating each one. Here's it under a microscope view. I think it's a pretty cool view to see this in, so I just decided to include it. Yes, I know the surface finishes could be a lot better. So now I'm going to go ahead and make the foil pocket for the heat treat, and I think most of this I'm just going to yap about the new camera. So as I was saying, I ended up getting a new camera. I'll insert a video of it right here, but I got a Sony A2 or an A7 II. It's a nice little camera, mirrorless. I got a couple lenses for it, and this video is all shot with the same lens because I don't have the other ones yet. Actually just got the camera in yesterday as of recording. And so yeah, it's a fun little camera. I quite like it. Part of the biggest issue I had with my process was dealing with footage. I was doing all the previous videos on my phone. Frankly, for footage quality, I would never have upgraded. My phone actually shoots at higher quality footage, or well, higher quality. It's a much smaller sensor, but dealing with that footage though is quite the process. Getting it off of my iPhone onto my Windows computer was just a really big. It was a big deal. It wasn't as simple as I'd like. And so I'd end up spending, if I had a long video, this will be a reasonably short video, but if I had a longer video, there'd be a couple hours of footage I'd have to transfer. And that not only uses up a lot of space on my phone, but it also just takes a really long time to transfer the way I had to transfer it because no direct transfers were working. So I had to upload it to Google Drive, and then I download it onto my computer, and then I have to pay for Google's Drive subscription, which I'm actually keeping just because it's kind of nice. It's not very expensive. But it's just a super annoying process, whereas with an actual camera, I just take the SD card and plug it in. It's super easy. I really like it. So this will hopefully help just kind of remove that annoying barrier where I just didn't want to deal with the footage stuff because, when I say it, it sounds simple, but it would take days to get the transfer done. So I'd avoid working on YouTube videos just because of the footage problem. So hopefully that fixes that. The other things are just kind of like small things where it's just kind of annoying do it with your phone. Like, you can't use your phone. If you set up like an hour-long time lapse for machining or something like that, then it's like, well, you can't do anything else on your phone while that's happening. And then if you got like a phone call while you're filming or something, you cut it off. Anyways, just kind of annoying stuff. Figured I'd give you a quick update. I also moved shops, which is a big amount of time. I ended up moving in March. So I got the new machine in December, which was my last video. And then in March, I ended up moving shops. I actually might be getting another machine soon, so I might have a video on that pretty quick, learning that machine. I'm not going to say what it is yet, because I might not be getting it. But if I do, you'll see that video probably reasonably soon. I'm going to be aiming for a video a month in the future. As you'll see, my last video was like 7 months ago now. It's been a hot minute. So gonna really be trying to get these down a little bit more. Maybe not every month, maybe every other month. But with this new process, it should help me get this done a little quicker, make it a little easier. And, having spent as much money as I did on this setup, I will probably be a little more motivated to actually make videos with it. Hopefully, I sure hope so. Once the wrapping is done, I go ahead and dip the lock bar inserts into talc powder. And that seems like kind of pretty weird, but what it does is it keeps the steel from welding to the sheet. These only heat treat at 1950, so that probably wouldn't happen, but for higher temperatures, I make sure to use it when doing like MagnaCut or S35. But for this, I haven't really found it to be necessary. I just go ahead and do it anyways, just because that's part of my process, but that is what the talc powder is for, is to keep it from welding to the inside of that coupon, because if they weld, it becomes a really annoying problem. Once that's done, I go ahead and I squeeze all the air out of the coupon. I haven't actually seen anybody else do this. I doubt it's original to me, but I put some foam on some aluminum blocks, and then I just press the air out instead of using like a vacuum or something like this. I find it to be a much easier system. And this just gets all the excess air out of there, which keeps it from burning a little bit. I left the label on the steel, so it's going to burn anyways, but not enough to cause an issue. And then after that's done, I just go ahead and finish sealing up the packet. I just fold this last end over. Not a I go ahead and label on the outside, which is a bad idea in hindsight. I should have labeled the inside of it, because on the inside, the Sharpie would have survived. On the outside, you'll see in a moment, Sharpie does not survive even a little bit, so I'm going to have to figure out which one's which just through measuring or testing. Once that's done, I go ahead and throw them in the heat treat oven. I recommend using welding gloves for that because it's hot. Even at 1500 degrees, pretty hot. And then I let it get to temperature. While it's getting to temperature, I go ahead and set up my water block cooling system. I actually break this. I've used this hundreds of times, and I break it in this video because, of course, I do. So it's just it's an aquarium pump connected to an arbor press. I have plans to improve this. I actually bought some stuff to improve this and just haven't done it yet because that's how I roll. And so it just goes on like that, and then it works just like that. It's a pretty simple process. I'm not sure how I managed to break it, but I did. This is the piece I mentioned when I said I was looking to improve it. This is a pneumatic cylinder with a 3D printed frame, in which case I could just hook up air power and just pneumatically actuate these blocks, which I think would be better. So I actually just broke my water blocks. You couldn't really see it, so I didn't include it, but I'm trying to get that in there and not burn myself because it's really easy to touch that now. And then I go ahead and actuate the arbor press. I'm going to get out of the way of it in a second. I'm just really trying to get this jank thing to work because I broke it. And then you can see you can put pressure on it. Those water-cooled blocks are cooling it as soon as I plug them in. And, you know, it was a whole thing. I was dumping water on the floor. You're probably not going to see any of that because I was covering all of it, but it was a whole thing. These were kind of on their last leg of life. Despite using them hundreds of times, they just decided to die right now. Anyways, I went ahead and heat treated the next one, and then what I'm going to do is I'm going to temper them for an hour at 400 degrees, and then once that's done, I just need to clean them up, and you'll see the final product. Go ahead. You've seen how I put them together. You'll just see that they're hardened now. I'll do a hardness test, show you that they're about 55, and then it's pretty simple from there. Okay, so these are what they look like out of temper and heat treat, just the packet. I'm going to go ahead and cut the packet out, and you can see the parts. They do look a little burned, and they are a little burned because there was that label in there. You can actually see where the label was, but the parts themselves are going to be dimensionally stable. They're not going to have changed dimensionally, and you'll see that in a second. So now I'm going to go ahead and hardness test the piece of stock I machined the lock bar inserts out of. Because it went through the same hardness and tempering process the lock bar inserts did, it's going to be the exact same hardness, but then I don't have to damage the actual lock bar insert hardness testing them each individually because they're all going to be the same hardness. You can't read the dial indicator, but it came out to about 58 HRC, which is slightly higher than I aimed for, but it's about 5 HRC under the blades, so perfect for this application. So I went ahead and cleaned up one of those lock bar inserts off camera. If you want to see that process again, then just rewind the video back to where I was cleaning it up, and it's the exact same process. So here you can see everything put together. I wasn't going to make you watch it all again, and it works perfectly. These work great. This is the hardened one. It works exactly as intended, and it removed the detent lash, and everything is pretty good. I actually do measure it, and you know, this original measuring is a little bit more than it is, but once I got it actually set up properly, I measured to about 1/1000 of detent lash I could measure at that point. So like really good. So a little bit of room for improvement here, but it's not really anything you can feel. So I'll probably just change that on the next batch, but these are going to be good to go for this batch. If you enjoyed the video, thanks for watching. If you're interested in checking out some of my knives or my products, you can check out my website at Frankenforge Blades. I'll, if I remember, put a little graphic on the screen. And yeah, thanks for watching. If you have any video suggestions or if there's anything else you'd like to see from me, definitely leave a comment and I will happily look at those. Like I said previously, I'm going to be trying to do more videos, so I'll be trying to do that. No promises, though.